Hello everyone, and today is the 19th of December, and while I was skipping some of the days, we are in a row of solving the day 15 till day 19. Today, in this video, we'll be solving day 17 with AI. And I was asked in the previous video, in the previous stream, that what's the point? Why do I not solving those problems by myself and I'm using AI, LLMs to solve them? And that's the key the key thing of these streams, this idea. This is an experiment in order to understand whether the AI of the level that's reached currently, the current level of AI, of development of the LLMs, are they able to solve such problems that involves this complex thinking and it's creative thinking. There are a lot of things that can confuse the model, can confuse the human, and whether it should be able to come up with some algorithm that will actually solve this from few shots, like one shot or two, maximum 3 shots, without much additional prompting or guidance in terms of solving. So just to test whether the model itself is able to solve these problems. And that's why I'm testing around all those different models, starting from the dumbest ones, like the smallest ones, which are not open source, which are like powerful models, but still they're small, like Claude 3.5 HiQ, like GPT-4o Mini, and going towards the smartest model, like O1, O1 Mini, O1 Pro, and Claude 3.5 Sonnet. By the way, Gemini 1206 is quite a good model as well, but sometimes it just, for some tasks, it fails. In any case, it got quite a large context window, like 2 million tokens. No model has such a large window, but not for our task. It's not a bit applicable for our tasks. So we're ready to head on day 17. As always, we are starting by reading the task, fully reading the task, and solving the first part with the O1 Mini. See if it gets it correctly, and then we'll get both parts in one prompt to all of the other models and see how they will approach this problem. Let's go reading.
The historians push the button on their strange device, but this time you all just feel like you're falling. Situation critical, the device announces in a familiar voice. Bootstrapping process failed. Initializing debugger. The small handheld device suddenly unfolds into an entire computer. The historians look around nervously before one of them tosses it to you. This seems to be a 3-bit computer. Its program is a list of 3-bit numbers 0 through 7, like 0.123. The computer also has 3 registers named A, B, and C, but these registers aren't limited to 3 bits and can instead hold any integer.
Okay, so this is another kind of problem. Seems like this task is not about solving a maze or just moving and navigating the map like it was 2 or 3 or 4 days before. Like in a row, we get maps, and mazes. Now it's a computer that we are programming. We have these registers, and they do something. I remember these kind of tasks. Let's read the second part.
The computer knows 8 instructions, each identified by a 3-bit number called the instruction's opcode.
So
each instruction also reads the 3-bit number after it as an input. This is called its operand. A number called the instruction pointer identifies the position in the program from which the next opcode will be read. It starts at 0, pointing at the first 3-bit number in the program. Except for jump instructions, the instruction pointer increases by 2 after each instruction is processed to move past the instruction's opcode and its operand. If the computer tries to read an opcode past the end of the program, it instead halts.
Okay, so we have opcodes, operation codes, and instructions, and they do something. And yeah, I remember the kind of task was in day 2018 that I've solved. I spent like up to 6 hours in order to solve this.
So the program 0.123 would run the instruction whose opcode is 0 and pass it the operand 1, then run the instruction having opcode 2 and pass it the operand 3, then halt. There are 2 types of operands. Each instruction specifies the type of its operand. The value of a literal operand is the operand itself. For example, the value of the literal operand 7 is the number 7. The value of a combo operand can be found as follows.
Combo operands 0 through 3 represent literal values. Combo operand 4 represents value of register A, combo 5 register B, combo 6 C, operand 7 reserved and will not appear in valid programs. The 8 instructions are as follows. Alright. So puzzle input is register A, register B, register C, then a program. Oh, that's quite a bit of text.
The 8 instructions are as follows. The ADV instruction opcode 0 performs division. The numerator is the value in the A register. The denominator is found by raising 2 to the power of the instruction's combo operand. So an operand of 2 would divide A by 4, 2 upon 2. An operand of 5 would divide A by 2 upon B. The result of the division operation is truncated to an integer and then written to the A register. The BXL instruction, opcode 1, calculates the bitwise XOR of register B and the instruction's literal operand, then stores the result in register B. The BST instruction, opcode 2, calculates the value of its combo operand modulo 8, thereby keeping only its lowest 3 bits, then writes that value to the B register.
I won't be reading all of the opcodes, it would take some time. If you are approaching this problem, you would like to read all of them and understand correctly. But the basic idea is that you have different operations, which is bitwise XOR, opcode 2 is combos, module 8 and something. This is an instruction, this opcode 3 does nothing in register A, however A is not 0, then jumps and does something. So there is a lot of confusing but complex instruction combined of a lot of different things to do. And probably if you write this down and just manually go one by one by all the operators and all the instructions and understand what it's doing, you'll be solving these tasks pretty easy. Just complex, not about the algorithm, but about that a lot of different instructions you need to follow and a lot of different conditions, I would say. So here are examples of an instruction operation. If register C contains 9, the program 2 and 6 will set register B to 1. So we have those registers, they will change. There are only ABC, and then program is this. And when we go through these numbers, we do something with the registers. So we first have to determine what the program is trying to output. To do this, initialize the registers and given values, then run the given program, collecting the output, any output produced by out instructions. Always join the values produced by out instructions with commas. After the above program holds, if it's the final output will be this one. Yeah, I understood like almost nothing. What? what the output result, how did it get to the output. Any case, we are opening day 16 O1 mini, and I'm placing task description O1 mini. Also, I'll be prompting it. Yeah, I've just, where was my first prompt? So that both tasks. Okay, I'll copy the latest part. So, and I'll change that. So task both parts. Currently task part 1. Yeah. O1 mini. I engined. I anticipate that O1 mini should be able to solve this from the first attempt, because O1 mini is quite good in solving programming, not tough problems like when you require like a creative thinking or something, but when you have explicitly told it what you should do, the steps, the instructions, which is contained inside all those instructions. So yeah, implemented the task. What? Okay, so there's a problem with my. I'm sorry. Yeah, I need to run it again. It's just a problem with my prompt that I'm asking it cursor settings to analyze the code, the right explanation and something. So provide a clear explanation with code suggestion how it adheres best practices and writing. Okay, do this like oh no, I'll be just removing this part. Probably just not needed. It's in my like system prompt in cursor settings. Okay, so now we have something for part 1. We have these opcodes, and code is not pretty big. Probably it will be able to solve this one, and the input is not very large. So let's go input. Let's see if it. Okay, so I'm in day 16 now. Solution and Python O1 mini. Let's go. None. Why? What did we? Yeah, O1 mini. Day 17. Sorry. Yeah, so okay. Day 16, 17, and solutions. Let's go. All right, so invalid parsing. I'd really like it to solve this problem. I'm just telling. I'll be just saying that it doesn't understand which is the. Okay, I see now. I remember what I did before. So in terms of prompting, I will be doing this. Parse their input with a regexp. This is what usually helps it to parse it properly, because sometimes the model tries to split the data, and when it's the next, like, it didn't think through how the input file, the input data is structured, or just confused by some reason. It is not able to parse the input file by just splitting the numbers, or just splitting the different parts of the input. So yeah, I'll be asking. I'm asking you to use regular expressions. Now it should be able to parse the input correctly. Let's see. Yeah, it got us something. And the code, by the way, is much cleaner now. And hopefully it would work at least. Yeah, alright, so we got something. We got something interesting that is not a number, it's a sequence of numbers. And no, it's not the right answer. It's not the right answer. No points for 01 mini for now. Let's go to 01. Let's go to 01. Alright, so just thought about a couple of seconds, didn't think a lot. Probably it's not so complex for it, but yeah, it's step by step, includes the step-by-step reasoning, instruction sets. This is much clearer now what should be done. Determining the combo operand. Okay, this is the combination, and yeah, well, there was an error in response for some reason. Thank you OpenAI, but it was able to write the most of it. So we are writing to 01 this solution, and yeah, this will be auto-completed. 01, let's go. Yeah, we have another answer. Let's see if it's correct. Yay! 1 gold star. Perfect. Thank you for solving it, 01. So let's briefly read the part 2 and then prompt all other models. What's changed?
Digging deeper in the device's manual, you discover the problem. This program is supposed to output another copy of the program. Unfortunately, the value in register A seems to have been corrupted. You'll need to find a new value to which you can initialize register A so that the program's output instructions produce an exact copy of the program itself.
Okay, so this one is a much more creative approach. Should be not just blatantly just dumb solution to iterate through all possible of what registers, register numbers or something. Now you need to find a new value which you can initialize register A. So instead of this number. So the program will be a copy of itself. It's just the same problem, the same sequence of numbers. This program outputs of itself if register A is instead initialized to this number. If the original initial value is 2024, what is the lowest positive initial value for register A that causes program to output copy itself? So, alright, let's copy the full description. No, I'll be copying only part 2 now, and I'll be putting it inside 01 mini. Let's give it one more chance. So let's go part 2. Okay, project structure. So solve the task, both parts. Provide full working solution, parse using regex, and what else? Yeah, that's it. Probably that's it. I'll be copying this prompt. Let's get Omini another chance. Yeah, continue revert. Let's go to 01 again. Just prompt it. Let's go to DeepSeek. Yeah, with DeepThink enabled, then Gemini, and then what else? Yeah. Claude we'll start from haiku. And yeah, let's solve. And let's see which one gets it first. Alright, so O1 is already writing something. And yeah, it's finished. Let's see. O1. How did it do? O1. Okay, so the first one is the same still. The second part is calculating currently, so we'll see how it will get. I was expecting that the part 2 should take some time to calculate. While we're waiting, we can see another result from O1 Mini. And yeah, alright, 3-bit computer. I like that it has created a class. 3-bit computer, program register IP output, get operand value, execute instruction, different opcodes, run, okay, get output. Parse program, part 1. We create this computer, we run, we get output. Very nice, clean code. Finally, then for the second part, we need to find initial A, and it just probably do this by not any creative approach, just running the computer and changing the initial A. Yeah, it's just increasing it by 1. Yeah, it will take a lot of time to compute. I wonder whether O1 did the same thing for the part 2. Let's see. Let's see. Part 1, part 2. Okay, let's see. Okay, A candidate 1, output. Okay, it's just doing the same thing. So, apparently the solution from O1 and O1 Mini would be the same for the part 2. If O1 Mini will be able to solve part 1. Let's split this and Python. Python O1 Mini, and there is invalid opcode. Okay, why though? Is it in a parsing? Computer run, execute instruction. All right. No, sorry. O1 Mini. I'm very sorry, but was it able to solve the first? No, it didn't. So failure, full failure for O1 Mini. Failed. Okay, let's go. O1 is not failed. It's actually a success. And then O1 part 2 is still calculating. Let's go while it's doing. Run the DeepSeek solution. Date 17 DeepSeek Pi. Yay. Let's go create another terminal. Python. Where are we? Okay, so cd day 17, cd solutions, and Python DeepSeek. Okay, we get some answer. I don't remember by heart. 31463 in the end. 31463. Okay, so for DeepSeek, the first one is correct. And by the way, we have -1 for the second one, which is I'm pretty sure is not correct. Okay, so let's just add the DeepSeek success and failed. Okay, what do we have here? Do we have an answer? No, it just I think it will take a while, or even it won't be able to solve because it should take very long time to iterate through all the A possible values and run this program so many times. But yeah, what did I copy? Gemini. No. what? Yeah, Gemini. Let's see. Seems like it's correct. What's about an input? Seems like 60. Yeah, it's correctly now. Now let's try Gemini. The answer is correct again. So right, so most of the models seem to are able to solve the first problem, but with the second one, I think we need something more creative. I will be prompting O1 Pro now, because I'm pretty sure that O1, like with this iterative approach, you won't be able to get the correct answer in a adequate timescale. So let's write down the results of Gemini. Where's Gemini? Success failed. Yeah, I'm still not sure whether it's fail for the second one, but probably yes. It's definitely fail for DeepSeek. Yeah, let's go. What do we have for which one is this one? IQ. Let's place it here. And yeah, they are still calculating. I'll give them a chance, but day 17 solutions Python plot IQ. Okay, we have a problem with parsing, even though I've asked it to parse with regular expressions. Yeah. Yeah, I think I've explicitly told that it needs to use regular expressions. Yeah. I will rerun it because it just failed to comply with the with what I asked it to do. Yeah, again, just it didn't use regular expressions for now. Yeah, sorry. Yeah, let's try it again. Anyway. Yeah, none. Okay. Fail for you. Where do I have full prompt? It's over there. Okay, Haiku. Here's the solution for Haiku. Let's go with Sonnet. So what do we have now? Gemini, still thinking. DeepSeek, still thinking. O1, we will choose O1 Pro. Instead, copy O1 Pro mode. And yeah, let's go. Hopefully we'll understand that the solution of part 2 should not be the same as part 1, just iterating on the A. But yeah, we'll see how it goes. Yeah, Sonnet. We get a result from Sonnet. And it uses regular expression. That's good. Sonnet. Yeah, we get an answer from the Sonnet for the first part, which is correct. Let's see how it deal with this second part though. Yeah, just the same way, just running the program. It did it like more, like just returned -1. How did it run all the okay. Failure for the second part. So, Claude Sonnet, success and failed. Gemini, same success. I did write it before. Gemini, Haiku is success. Did it? No, it's failed to pass. Okay, what do we have? Nothing from O1 Pro still. Sonnet is ready. Yeah, just start new chart. Okay, we are still waiting for Sonnet for O1 Pro answer. Let's see if something is. Yeah, there's no answer for part 2. I will stop this because it would take quite a bit of time. Okay, so now let's see when O1 Pro will stop. We'll revise whether the task 2, like part 2, is solved differently than the part 1, not just iterating on a register. Okay, and part 2, yeah, a candidate just doubted. Okay, so I'll consider this as fail. I'll ask it additionally and wait until the answer. So now it would take a very long time to calculate the A register with just iterative approach. Solve this more creatively. So let's see how long did it thought? 2 minutes 13 seconds. Yeah, so it will probably think for around the same time again. Yeah, and this is just what we are waiting for. The latest model that we are testing for this day 17 challenge. What do you think? What do you think so far about those models? I'll be creating a map, like a chart of comparison of different models, how they performed during all of those days. And I have one already, but it was until day 9. I'll show you now. So this is the chart. So you can see this until day 9, and not all the problems I solved with O1, because I didn't have a O1 subscription for Pro mode. I had very tiny limit, like 50 requests for the week, and therefore I didn't just give it every problem. But now I can do that. But for other models, you can see that they start to fail. Mostly the smaller models start failing after day 6. The second part is different. It's they fail. The smaller models failed to solve it even for day 4. Occasionally solving for some of the other days. Yeah, and that's it. Claude 3.5 Sonnet solved quite a lot of tasks. O1 Mini as well. O1 not so much, but we'll see that later. Here's another chart of comparison. So Claude 3.5 Sonnet had the best percentage rate of solving all of the tasks. I think it's the only one attempt, like using only one shot. O1 Mini as well, almost the same rate. O1 had a little problem with solving, like giving the correct code, like giving the actual code, not placeholders for code. For some reason, O1 did ask me to implement by myself. GPT-4o had of the big models. GPT-4o had the least percentage of success rate. For the smaller models, we can see that Claude Haiku solved around 50% of the tasks. GPT-4o mini solved even less. Okay, so this is it, and even though we spent time to review the chart, O1 Pro is still thinking, and we have, okay, so taking the puzzle, decoding output, deciphering instructions, translating ideas. Oh, it's quite a bit. Adjusting my view, inferring how XOR constraints A initial bits non-values, aligning bit constraints, piecing together bits, pondering systematic backtracking, testing all possible combinations of bits up to 3, multiply number of out instructions, and ensuring constraints are satisfied to pinpoint this model value. Okay, so it's alright, we have something. Find A for self-replication, which is what? A current is now initial. After sequence of divisions, output yields target. Okay, so now it's definitely much more complicated. For value and reverse target, which is what is that output. Okay, so it's slightly different approach. Let's add another file, O1 Pro, and let's see how it did it. All right, we have a number, which is a large number, and possibly is too low. It's even too low. Okay, I'll consider this as fail for O1 Pro as well. We probably would we could probably do like additional prompting and wait another 5 minutes. By the way, how long did it take for this to solve? 4 minutes. So yeah, that's why when you go to the leaderboard of the day 17 that we have solved, for some reason people had both stars in 14 seconds. How did they do that? Okay, so I'm assuming that, like, what did they use for solving this? How do you solve this task? Both stars in only 50. Oh no, sorry, I'm very wrong. It's 14 minutes, so no problem. 14 minutes, yeah, considerable amount of time. Like some people, like 100 places, 44 minutes, and the first star was get. Like, this is definitely LLM, 28 seconds. Yeah, but then, yeah, under 3 minutes. Okay. All right. So we are ready to move on to the day 18, which will be like, yeah, we didn't get a star for day 17, and for day 15. We'll move to day 18 and we'll start in a few minutes. Just let me submit the code to the GitHub, and yeah, I'll see you in the next one. Just wait on the channel until another stream appears.